Welcome back to Inquisitive Kids. In this video, we will be talking about definition and derivation. In this lesson, we're going to continue to work on our abstract math and logical thinking. So this is our third lesson of this unit, and we're going to be working on definition and derivation. So what is definition and derivation? Our learning goals for today is to understand what are axioms and theorems in math, and understand the importance of proving propositions and derivation. So how can we prove a proposition to be true? Here are 4 main points for you to understand. So vocabulary and math words are just the words and terms used in math. An axiom is a statement or proposition which is regarded as being established, accepted, or self-evidently true. So it's like a very basic fact that nobody really needs to prove. So they're like the foundations of math. And derivation is a sequence of steps, logical or computational, from one result to another. So it's basically your thinking, but in the language of math. Let's say that you come up with a conclusion. You have to explain very clearly why that's your conclusion. You have to write because this, therefore this, therefore this, and so on. And a theorem is a true proposition that has already been proven. So if we have our axioms plus some given conditions from this specific problem, we're going to use our derivation and logical thinking to prove the propositions true or false. This might be a little confusing at first, but throughout the slides you'll start to understand. This process of proof is called derivation. And true propositions that have already gone through derivation are called theorems. So here's a lot. Let me go through this one by one. In our lessons, we use 9 axioms. We've already learned 8 of them. Number 1, a straight line may be drawn between any 2 points. Number 2, the shortest distance between 2 points is a line segment in between. Again, remember, a line segment is straight. Number 3, on a plane, there is only one line perpendicular to each point. So let's say that you have a line over here. You only have one other line that's perpendicular to it. I'm sorry, but let's just say that this is a right angle. You won't have 2 different perpendicular lines. And number 4, when 2 straight lines are cut by a third straight line and the transversal angles are equal, then the 2 straight lines are parallel. Every straight line is only parallel to one other straight line through a point outside of it. Let's say that we have a straight line, and we have a point that's outside of this straight line, and there is only one other line through this point that is parallel to the original straight line. Number 6, 2 triangles whose sides and interior angles are equal are congruent. That's not SSS. If 2 angles in the side in between of 2 triangles are congruent, then these triangles are congruent. So let's say that we have 2 triangles, and we know that these 2 angles are the same, and this side in between these 2 angles are the same, then these 2 triangles are congruent. That's a symbol for congruent. So that would be ASA, angle, side, angle. If 2 triangles have sides that are the same, then they are congruent. So as you can see, these 8 axioms are all something that has to do with geometry. The 9th axiom is the property of equality and inequality. We haven't really learned about it yet. So in an equation or inequality, a quantity can be substituted by its equal. So this property is an axiom. Adding the same value to both sides of an equation or inequality does not change it. The 9th axiom is algebra. Basically, all of algebra is based off of this one axiom. Now I want you to prove the vertical angles theorem. Here we have vertical angles. As shown in the figure, line AB intersects line CD at point O. Angle AOC and angle BOD are vertical angles. I want you to prove angle AOC equals angle BOD. So here's our derivation process. Because line AB and line CD intersects at point O, and that's given, therefore angle AOB and angle COD are both straight angles. So that's the definition of what a straight angle is. Therefore, again, angle AOC plus angle AOD equals 180 degrees. That's the definition of supplementary angles. And angle BOD plus angle AOD equals 180 degrees. Therefore, again, angle AOC equals angle BOD. Supplementary angles of the same angle are equal. So this is how you would write your derivation process when you're proving something. Here we're trying to prove that angle AOC equals angle BOD. We are using two mathematical symbols, because and therefore. After every line you have to write parentheses and do further explanation. So line AB and line CD intersects at point O, and that is given. And in the second line, in the parentheses, we wrote definition of a straight angle. And as you can see, here we have three therefores. Every conclusion followed another conclusion. Here's some more practice. Example 2, given B is parallel to C, A is perpendicular to B. Prove A is perpendicular to C. Pause the video and see if you can write out a mathematical derivation. So we know that A is perpendicular to B. That's given. Therefore, angle 1 is 90 degrees. That's the definition of being perpendicular. And also, B is parallel to C, and that's given. So therefore, angle 2 equals angle 1, which equals 90 degrees, because two parallel lines have congruent transversal angles. Therefore, A is perpendicular to C, and because that's the definition of what perpendicular is, it means 90 degrees. Class summary. Today we learned about propositions again. An axiom is a statement or proposition which is regarded as being established, accepted, or self-evidently true, and a definition is a proved true proposition. A derivation is the process of proof. Here, it's not definition. That's actually what a theorem is. So I hope you learned something useful from this video, and I'll see you in the next lesson.